everyone, this is Kruti Chatterjee, Assistant Professor in LJ Institute of Engineering and Technology in the Department of Electrical Science. This video is about the subject AHEDABAD and Communication System. From this video, limitations of the bandwidth in the conventional AM system and at the cost of the increased system complexity, there are three types of the modulations. One is the VSB, that is double sideband suppressed carrier modulation, single sideband suppressed carrier modulation, SSB, vestigial sideband modulation, VSB. It is the amplitude spectrum of an AM wave, which consists of the carrier wave and the two sideband. Here the x-axis represents the frequency and y-axis represents the amplitude. Thus, the carrier having the frequency fc, it is fc minus fm. This is fc plus fm. So, the bandwidth required for the modulation is twice fm. We can calculate it by using maximum frequency minus minimum frequency, that is equal to fc plus fm minus fc minus fm. This is equal to twice fm. Sideband. What is a sideband? It's a band of frequency containing power which are the lower and higher frequency of the carrier frequency. As I always say, the sideband contains the same information. So, we have also seen that the amplitude of both the sideband, that is also same, it is the MVC by 2. So, if the carrier is suppressed and power the same is distributed to the two sideband, and such a process that is referred to as a double sideband suppressed carrier. It is the spectrum of the double sideband suppressed carrier, which consists of the lower sideband, upper sideband, and as we know that there is no information in the carrier, so we can suppress the carrier and we can save the power in the transmission. So carrier is suppressed and sidebands are allowed for the transmission. So this is the spectrum of VSB SC. FC plus FM for the lower sideband and FC minus FM for lower sideband, FC plus FM for higher sideband. SSBSC, single sideband suppressed carrier. Both the sideband contains the same information. There is no information in the carrier. To save the bandwidth and to save the power, we can transmit either of the sideband and we can suppress the carrier. So this SSBSC or SSB system, which transmit a single sideband as a higher power, as the power loaded for both the carrier and the other sideband is utilized in transmitting the single this sideband. Hence, the modulation done using this SSB technique is called the SSB modulation. The process of suppressing one of the sideband along with the carrier and transmitting a single sideband is called single sideband suppressed carrier system, or simply SSBSC or SSB. It is the amplitude spectrum for the SSBSC. In this, the lower sideband we are suppressing the position of carrier. You can see that can be also suppressed, and the upper sideband, that is FC plus FN, that is choose for the transmission. So carrier and a sideband are suppressed, and single sideband is allowed for the transmission. There are various advantages of the single sideband modulation. That bandwidth of the spectrum space occupied is lesser than the AM and VSB signals. Transmission of more number of signals is allowed. Power is saved. High power signal can be transmitted. Less amount of noise is present, and signal padding is less likely to occur. The disadvantage of the single sideband modulation, that is generation and the detection of the SSB signal, it's a complex process, and sometimes the quality that can be also affected unless the SSB transmitter and the receiver have an excellent frequency statement. The various applications of the SSB modulations are there. So the very first thing that we discussed about the power saving. So power saving requirement and the low bandwidth requirement applications, we must go for the sideband modulation. In land, air, maritime, mobile communications, sideband modulations can be used. In point-to-point communications, the sideband modulation can be used. In the radio communication, television, telemetry, radar communication, sideband modulations can be used. In the military applications, also the sideband modulations can be used. Now, in case of the SSB modulation, when a sideband is passed through the filter, bandpass filter, may not work perfectly in the practice. So, as a result of, we may get the information loss. So, to avoid such kind of loss, the technique is chosen, that is the compromise between the DSBSC and the SSB. So, that is known as the vestigial sideband technique. And the word vestige, which means a part from which the name is derived. So in the vestigial sideband, both of the sidebands are not required for the transmission. So as it is a waste, but a single sideband if transmitted leads to loss of information. So there is always the technique required, which is the solution for this both loss. So it is the vestigial sideband. So vestigial sideband modulation or VSB modulation is the process where a part of the signal, that is called the vestige, is modulated along with the one sideband. A VSB signal can be plotted as shown in the figure. So here you can see that this is the spectrum, okay, which is the spectrum having the two frequency. Here you can see this, it is the USB. So what we are doing? The whole USB we are transmitting. Now part of the LSB also considered while transmitting the signal, so that we are using the sharp filters which providing the response, and so that what happened, that the information that will be at this position cannot be lost. So to protect this part of the LSB, that is also transmitted during the transmission. So here we can see that the other part of the LSB that get wastage. So that is why it is known as the vestigial sideband. These are the two guard band. Guard band is required to protect this particular channel. So this is the VSB modulation. So along with the upper sideband, a part of the lower sideband is also being transmitted in this technique. A guard band of very small width, that is either side of the VSB, in order to avoid the interference. And this modulation that mostly used in the television transmission. The advantage of the VSB modulation are, it's highly efficient, we can say, reduction in bandwidth, filter design is easy as high accuracy is not needed, the transmission of low frequency component possible without a difficulty, possesses good phase characteristics. Disadvantage of the VSB modulation: when you compare the required bandwidth compared to the ASSB, here the bandwidth that is required more compared to SSB. Why? Because we are also taking the part of the LSB. So bandwidth when compared to single sideband modulation, the requirement is greater. Demodulation, that is complex. So these are the disadvantages of the VSB modulation. Application of VSB: the most prominent and standard application of the VSB, that is in the transmission of the television signals. Also, this is the most convenient and efficient technique when, so we discussed about the VSB modulation and application. So this way, the bandwidth efficient AM modulation technique that can be used for the variety of the applications. In the next session, we will solve the various examples related to all the techniques, so that can be the concept can be more clear about solving the examples. So this way, whenever in the project you are doing, you can go for the selection of the technique based on their advantage, their disadvantage, how much power you want to save, how much power you want to transmit, okay, how much bandwidth you want to save, okay. So according to that, looking at all the parameters, we can also save we can also choose the technique for the transmission of the signals. So as the module, starting from the modulation, we have discussed, and amplitude spectrum we derived, the frequency spectrum for the channel that we derived. Then after we found out the modulation index, so the amount of the modulation, that also we have seen. These all the parameters that we discussed, so you can start solving it by your own, and we can also discuss later about the examples of this. So this way we can discuss it. So thank you very much.